Okay, hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. Okay, so welcome back to our class. Okay, for today's class, we're going to continue from our previous class. Okay, for today's class, we're going to learn two things. Okay, so the first one is the learning standard is multiply a matrix by a number. Okay, so how to multiply a matrix by a number? Okay, for example, you look at this yellow box. Okay, it is given that matrix A, you have A, B, C, D, and N is a number. Hence, if you multiply N with matrix A, it actually looks like this. Okay, N outside of the matrix, and then this is the matrix. You just multiply in the N, so it will become NA, NB, NC, ND, where N is known as a scalar. Multiplication of a matrix by a number is known as a scalar multiplication. Look over here. When a matrix is multiplied by a real number, that real number is called a scalar. So let's have a look at the first example. Example 11. Given that D is negative 5, 4, 2, 1, calculate 3D. It means, 3D, you actually have a number 3 and you multiply with matrix D, 5, 4, 2, 1. And how to solve this scalar multiplication? You just multiply this 3 to each element inside. So your final answer will be 3 times negative 5 is negative 15, 3 times 4, 12, 3 times 2, 6, 3 times 1 is 3. The same for B. So you have negative 1 over 2D. It's actually look like this, negative 1 over 2, and then D is negative 5, 4, 2, and 1. So just simply add in the scalar. So you will get negative half times negative 5 is 5 over 2. Negative half times 4, negative times positive, negative 2. Then negative half times 2, negative times positive, negative 1. Negative half times 1, negative 1 over 2. As simple as that. Next, example 12. Given that P and Q, calculate 3 times P minus Q. So how to solve this kind of problem? You just follow this one. You have 3 bracket P minus Q. So write it back. So 3. So inside you have P. P is 7, 9, negative 3, 8, 6, 12, minus Q. Q is 2, negative 3, 1, 5, 0, 4. We know that we need to do the bracket first. So how to subtract two matrix? You have learned it from previous class. What you do is 7 minus 2, 9 minus 3, and so on. So let's do it one by one. 7 minus 2 is 5. 9 minus 3 is actually 9 plus 3 is 12. And then negative 3 minus 1 is negative 4. 8 minus 5 is 3. 6 minus 0 is 6. And 12 minus 4 is 8. Okay. And leave you with this one. Okay, so what you do with this one, okay, you just simply multiply in the scalar with the element in the matrix. Okay, so your final answer will be 3 times 5 is 15. 3 times 12 is 36. 3 times negative 4 is negative 12. 3 times 3 is 9. 3 times 6 is 18. And 3 times 8 is 24. Okay? Okay, let's move forward to number 13, example 13, okay? Given that, okay, half 4 12 minus x negative 3 is equals to 5y. Calculate the value of x and y. Okay, so we solve A first. Okay, you have a scalar multiplication over here, so you need to solve this one first. Okay, so you just multiply in the scalar. So half times 4 is 2. Half times 12 is 6. Minus x minus 3 is equals to 5y. Okay, now when we try to solve for x, okay, don't forget the operation. Okay, so the top part is to solve for x. Okay, so you write down the elements. So you have 2 minus x is equals to 5. Okay, so negative x is equals to 5 minus 2. Negative x is 3. But the question asks for x, not negative x. Okay, so x is equals to negative 3. Okay, that is the first part. And then for y, you look at the bottom part. Sorry. You look at the bottom part of the matrix. Okay. So you have 6 minus 3 is equals to y. So negative is plus. So 6 plus 3 is y. So y is equals to 9. Okay. And then we try to solve B. Okay. So given that 4R plus this matrix is equals to this matrix, calculate matrix R. Okay, so what we need to do over here is, okay, so write down 4R plus 902 negative 3 is equals to negative 3 4 10 1. Okay, so we want 4R. Okay, so this matrix, okay, you can move to the next, move to the right. Okay, so you will get 4R is equals to negative 3 4 10 1. So over here is plus, so it will become minus 902 negative 3. Okay, so 4R. Okay, so this is a subtraction of two matrix. Okay, so you can do it one by one. Negative 3 minus 9 is actually negative 12. 4 minus 0 is 4. 10 minus 2 is 8. 1 minus 3 is 1 minus minus is plus, so 4. Okay, the question asks for the value of matrix R, but over here you have 4R, okay? So you need to divide 4 both sides. Okay, so you will get r is equals to 1 over 4 negative 12 4 8 4. Okay, so you just multiply in this scalar multiplication. 1 over 4 times negative 12, you will get negative 3. 1 over 4 times 4 is 1. 1 over 4 times 8 is 2. And 1 over 4 times 4 is 1. So this is the value of matrix R. Okay, let's proceed to number 14. Okay, so number 14, you have the average number of vehicles per day in the parking area for 5 working days is represented in table X. Okay, table Y represent the average number of vehicles per day on weekend. Okay, so actually table X is parking area on working days, okay, weekdays, and this is for the weekend. Okay, this one is Monday until Friday, this one is Saturday and Sunday. Calculate the number of vehicles parked at the parking area in a week. Okay, so actually what you need to know from this question is, okay, this is per day. Okay, so each day, so for Monday like this, for Tuesday like this, Wednesday, Thursday and Friday. This is the number for Saturday, and then again this the same figure for number of in Sunday. Okay, so what you need to do is okay, so on the weekdays, okay, per day. Okay, so you have changed the table into matrix form. So 42, 8, 20, 11. Okay, this is the number only for one day. So how many days are there in the weekdays? So you have 5. Okay, and then you have weekend. So you have 25, 5, 12 and 3. So this is only the figure for one day. So how many days are there during weekend? So you have 2 days. Okay, so the total number of vehicle parks in 1 week. Okay, so actually you have, okay, for example, I write it down as 5x plus 2y. Okay, so actually you have 5, 4, 2, 8, 20, 11 plus 2 25, 5, 12 and 3. So you have both sides the scalar multiplication, and then you have plus. Okay, so we solve the first part. So 5 times 20 is 210. 5 times 8 is 40. 5 times 20 is 100. 5 times 11 is 55. Plus, and then 2 times 25, 50. 2 times 5 is 10. 2 times 12 is 24. 2 times 3 is 6. And we have an addition of 2 matrix. So how to solve this part? You just add in the same element. So we have 210 and 50, and then you have 40 and 10, 100 and 24, and then 55 and 6. So just add these 2 numbers. So 210 plus 50, you have 260. 40 plus 10, you have 50. 100 plus 24 is 124. And finally 55 plus 6 is 61. Okay, I think it's quite simple for this learning standard. Okay, and then you have self-practice 2.2b. Okay, so what I want you to do is, okay, number 1, A, B, C. Number 2, A, D. Number 3, number 4, number 6, and number 7. Okay, so I want you to try 2.2b. I think the question is quite straightforward. I think it's quite simple, okay? But if you have any problem, you can ask me, okay? So let's proceed to the next learning standard. Okay, next learning standard is multiply two matrices. Okay, so actually there's a few criteria you need to look forward to before you multiply two matrices. Okay, okay, the most important things, okay, in multiply two matrices is, okay, you need to look at the size of the matrix. Okay, so actually what is the size of matrix? Okay, size of matrix is actually the dimension of the matrix. Okay, take a look at this example. Okay, for example, you have the first matrix and the second matrix. Okay, let's look at the dimension or size of the first matrix, the yellow one. So how to write dimension? Row and then column. Okay, so how many row? 1, 2. So you have 2 by how many column? 1, 2, 3. 2 by 3. Okay, and then you have, okay, the second one. Okay, how many row? 1, 2, 3. 3 by how many column? 1. Okay, before you multiply any matrix, okay, you need to check its dimension or sizes. Okay, over here you will see, okay, we have the same number, 3 and 3. Okay, in order to multiply two matrices, okay, this middle number must be the same. Okay, if you have 3 and 3, so you can straight away multiply your matrices. If you have different number over here, it means you cannot multiply the matrices. For example, you have 3 by 2 and 3 by 1. So look at the middle part. Okay, it's not the same, so it means you cannot multiply these matrices. Okay, so I hope this is the most important criteria before you multiply any matrix. Okay, okay, so let's have a look at the first example, example 15. Okay, it is given that matrix C is 8, 3, matrix D is 1, 2, negative 2, and 5. Determine whether multiplication CD and DC can be performed. If yes, state the order of the product of the matrices. Okay, so the question asks us to multiply two types of matrix. So first we have CD. Okay, so C first and then D. Okay, so let's have a look at the size or dimension of C. So C, how many row? 2 rows and 1 column. So we have 2 by 1. And then D is 2 by 2, so 2 by 2. So let's have a look at the middle part. Okay, so we have 1 and 2. So obviously you cannot multiply these matrices. Okay, so how can we write the reason? Okay, so multiplication CD cannot be performed because the number of column in C is not the same with the number of rows in D. Okay, so this is the main criteria before you multiply any matrices. Okay, next we try DC. Okay, if CD cannot be multiplied, it doesn't mean that DC cannot. Okay, so we need to inspect first. Okay, we need to try. So DC. Okay, so D, what is the dimension of D is 2 by 2. Okay, and then D is 2 by 1. 2 by 1. So look at the middle part. We have 2 and 2. So it means it can be multiplied. Okay, if it can be multiplied, so what is the order of the product? Okay, product is actually the hasil of the two multiplication. Okay, so if the middle part is the same, so the number left is actually the order of the product of the matrices. Okay, so we can write it as, okay, the product will be 2 by 1. Okay, so how can we properly write? Okay, so multiplication of DC can be done or performed because the number of column in D is the same with the number of rows in C. Okay, the order of DC is 2 by 1. Okay, so I hope you remember these criteria before you do any multiplication of matrix. Okay, let's forward with example 16. It is given that matrix A and matrix B. Okay, so we need to check the dimension first. Over here you have 2 by 2, over here is 2 by 2. So the middle number is the same, so no problem. And you know that your product will be 2 by 2. Okay, so for this type of examples, for this type of question, you can use this tip. Okay, but you can try this yourself after this, because I'm going to teach you other method, okay, by using column box because I think I prefer that one, so I hope you prefer to use that method too, but you also can use this one, no problem. Okay, so calculate AB. So the question asks you to multiply A and B. Okay, so please be alert that in matrices, okay, matrix, okay, the product of AB is not the same with BA. Okay, I want you to know these rules. Okay, not most of the time. Okay, so we try A. So A is 2, 3, 1, 5. B is 6, -7, -2, 1. Okay, so what you need to do is, okay, the first one, okay, you write it on the left part of your paper. So you have 2, 3, 1, 5. And then the second matrix, okay, B, you write it on top of the next part. So you have 6, -7, -2, 1. Okay. Okay, and then I want you to draw a box like this. Okay, with this method, you can know that your final product will be 2 by 2 matrix. Okay, you can note it straight away. Okay, so how to compute this one? Okay, so I show you one by one. Okay, the first one, 2 times 6. 2 times 6 is 12. Okay, 12, and then plus. Okay, must be plus. Okay, and then 3 times negative 2 is negative 6. Okay, and then 2 times negative 7. Okay, the first element times the first element, so negative 14 plus 3 times 1 is 3. Okay, next, okay, 1 times 6 is 6 plus 5 times negative 2 is negative 10. And then 1 times negative 7 is negative 7 plus 5 times 1 is 5. Okay, so your final answer of A, B will be okay, 12 minus 6 is 6. Negative 14 plus 3 is negative 11. 6 minus 10 is negative 4. Negative 7 plus 5 is negative 2. That's it. So this is your final answer for multiplication of AB. Okay, so I think it's more simple if you can use this method. Okay. Okay, so let's proceed to number 17. Okay, A. You have GE. Okay, so GE. So you need to write G first. Where is G? So you have 4, 3. So you write over here 4, 3. And then E. Okay, you write it at the top part. Okay, so 5, negative 1, 0, negative 4, 8, 7. And then I want you to draw a table. Okay, so by this you can know that your final answer will be, okay, 1 by 3 matrix. So where you have 1 row and 3 column. Okay, simple, right? Okay, then okay, we try to compute it one by one. Okay, 4 times 5 is 20 plus 3 times negative 4, negative 12. Okay, and then 4 times negative 1 is negative 4 plus 3 times 8 is 24. And the last one, 4 times 0 is 0 plus 3 times 7 is 21. Okay, so you know that your final answer will be 20 minus 12 is 8. Negative 4 plus 24 is 20. And 0 plus 21 is 21. So this is your final answer for A. Okay, next let's try B. Okay, B we have FG. So you need to write F first. So which one is F? F is negative 2, 7. So negative 2, 7. G is this one. So 4, 3. Then add in column. Okay. Okay, so by this one, you know that your final answer will be 2 by 2. Okay. So negative 2 times 4 is negative 8. 7 times 4 is 28. Negative 2 times 3 is negative 6. 7 times 3 is 21. So your final answer will be negative 8, negative 6, 28 and 21. That's it. Simple, right? It's very easy. Okay, then we have GF. So GF. So you need to write G first. Okay, G, where is G? So G is 4, 3. Okay, so 4, 4, 3. And then F, you have negative 2, 7. So you write it on the top. So negative 2, 7. So, okay, fill in your table. So this multiplication, so your final answer will be 1 by 1 matrix. Okay, so 4 times negative 2 is negative 8 plus 3 times 7 is 21. So your final answer is negative 8 plus 21 is 13. Okay, as simple as kacang. Okay, so far so good. Okay, next. Okay, number 18. Okay, 18, you have this question. Okay, it is given that matrix K and matrix L. Okay, calculate. Okay, you have L square, K L square, and L power of 3. Okay, so don't get scared if you have a look at this type of question. Okay, what is L square? Okay, L square is actually L times L, that's it. Okay, so L times L, so where is L? So you have negative 4, 2, 0, 1, the same one, so negative 4, 2, 0, 1, and then add in your table. So this will be 2 by 2. Okay, so the same method. Okay, negative 4 times negative 4, 16 plus 2 times 0 is 0. Negative 4 times 2 is negative 8 plus 2 times 1 is 2. 0 times negative 4 is 0 plus 1 times 0 is 0. 0 times 2 is 0 plus 1 times 1 is 1. Okay, so we know that L2, L square is equals to 16 negative 6, 0, 1. Okay, so let's move to the next question, KL square. So KL square, so the first part is K. So where is K? So this is K, so you have 3, 2, negative 1, 5, 4, negative 2 times L square, which you have compute from the previous one. So you have 16 negative 6, 0, 1. Okay, and then add in your table. So the product of this multiplication, so you will have how many rows? 1, 2, 3 rows. And then how many columns? 2 columns. So 3 by 2 matrix. Okay, so let's do it one by one. So 3 times 16 is 48 plus 2 times 0 is 0. Negative 1 times 16 is negative 16 plus 5 times 0 is 0. 4 times 16 is 64 plus negative 2 times 0 is 0. Okay, so settle for the first column. So let's move forward to the next column. 3 times negative 6 is negative 18 plus 2 times 1 is 2. Negative 1 times negative 6, negative, negative, positive 6 plus 5. And then 4 times negative 6 is negative 24 plus negative 2 times 1 is negative 2. So let's simplify all the elements. So you will get this one is 48, negative 16, 64, negative 16, 11, negative 26. Okay, so this is KL squared. Okay. So let's have a look at the last part. You have L cube. So this is actually means L times L squared. Okay. So where is L? L is negative 4, 2, 0, 1, and L squared is 16, negative 6, 0, 1. So add in your table. So this one, your final answer will be 2 by 2 also. Okay. So negative 4 times 16. Negative 64 plus 0. So this one is 0 plus 0. The next part is 2 times negative 6 is negative 12 plus 2 times negative 6, 1 times 1, 1. Oh, sorry. 2 times negative 6, 2 times 1 is 2. Okay. Then 1 times negative 6 is negative 6 plus 1 by 1 is 1. Okay. So your final answer will be negative 64, 0, negative 5, 10. Okay. Okay. But we know that L3 is also can be written as L squared times L. Am I right? Okay. So for this part, okay, I want you to try it yourself. Try it yourself. And try to compare with your previous answer. So you tell me either L squared is equals to L squared times L. Is it the same? Okay. So I want you to do this in your assignment. Okay. So please tell me. So L squared, is it equals to L squared times L? Okay. Then I will know that you understand multiplication of matrix. Okay. Okay, let's move to example 19. Okay, so given that, okay, multiplication of two matrix is equals to this matrix, calculate the value of x and y. Okay, so let's do it one by one. So you have 6x negative 5, 2, 3, 1, 4. And then you add in your table. So this one, you know that your final answer is how many rows? 1. How many column? 2. 1 by 2 matrix. Okay. So 6x times 2 is 12x plus negative 5 times 1 is negative 5. 6x times 3 is 18x. Okay, plus Negative 5 times 4 is negative 20. Okay, so we know that the answer for this multiplication is 12x minus 5 and 18x minus 20. Okay, is it correct? Okay, so I know that this matrix is equal to this matrix 7, 1 minus y. Okay, so it means, okay, if I solve this part, the answer is 7. And if I solve this part, the answer is this. Okay, so which one you must solve first? Okay, try to solve the problem with one unknown only. So you look at this yellow part, you only have x. If you look at the green part, you have x and y. So it's more complicated. So try to solve the yellow first. Okay, so yellow part, you have 12x minus 5 equals to 7. 12x equals to 7 plus 5. So x is equals to 7 plus 5 is 12 divided by 12. So x is equals to 1. And then the green part. So 18x is 1 minus 20 is equals to 1 minus y. So 18 minus 20 is negative 2 is equals to 1 minus y. So y is equals to 1 plus 2 is equals to 3. Okay, as simple as that. Am I right? It's simple, right? Okay, so let's move forward to the last example for this learning standard. Okay, the table below shows the share unit purchased by Khairil and Mahmud. Okay, you have share A, share B, Khairil and Mahmud. It is given that the prices of 1 unit of share A and 1 unit of share B during the purchase are 150 and 82 cents respectively. Calculate the total investment of Khairil and the total investment of Mahmud. Okay, so how to solve it? Okay, so we know that in order to get the total value in price, in ringgit, of the share units, okay, you need to multiply the number of unit with the prices, right? Okay, so what can you do? Okay, first you convert this table into matrix form. So you get 5,000, 4,000, 2,000 and 6,000. Okay, and the price of each unit for A is 150, for B is 82 cents. Okay, so you write the X on the top and A on the top and B at the bottom. Okay, so you have 1.5, 150 and 0.82 cents. Okay, okay, can you convert it? Okay, so it will look like this. Okay, so this is actually multiplication of two matrices. Okay, so let's multiply it. Okay, so you have 5,000, 4,000, 2,000, 6,000, and then you have the second matrix. You put it on the top, 1.50, 0.82. Okay, and add in your table. Okay, so this one, we know that your product will be how many rows? 2 rows and 1 column, so 2 by 1 matrix. Okay, so let's multiply 5,000. Okay, 5,000 times 1.5, 7,500 plus 4,000 times 0.82. 4,000 times 0.82 is 3280. Okay, and then 2,000 times 1.5 is 3,000 plus 6,000 times 0.82, you will get 4920. Okay, so your final answer will be, so you just add these two numbers. So 7500 times, plus 3280 is 10780, and 3000 plus 4920 is 7920. Okay, so usually in matrix you cannot leave your answer just like this, so you need to do some reasoning, okay, some explanation. Okay, so over here you can say that the total investment of Khairil and Mahmud are, so the first one is Khairil, the second one is Mahmud. So RM 10780 and RM 7920 respectively. Okay, so what is the meaning of respectively? So it means secara teratur lah. So Khairil is the first one, Mahmud is the second one. Okay, so I think that's it for this learning standard, okay, multiplication of two matrix. So I hope you're able to compute or calculate the multiplication of two matrix, okay, where you need to know that the main criteria before you do the multiplication is you need to check the dimension or the size of two matrix. If the middle number is the same, then you can proceed. If it's not the same, so you just stop there. You cannot do any further. Okay. So okay, for your assignment, so I want you to do number 1 A, E, F, okay, and then try number 2 A, B, C, and then you can try number 4, number 5 A, and number 6. Okay, so I give you 1 week to finish all the assignment. Okay, no need to rush. You can divide your assignment for each day you have. Okay, and please don't do it last minute. Okay, and if you have any problem, please keep in touch with me so I can explain to you much further. Okay, so this chapter is quite simple. It's just you want it or not. Okay, if you want to know this, to understand this chapter better, so you do more exercises. If you face any problem, so just ask me, no problem, or you can ask your fellow friends, okay, if they can help you. So I think that's all for today. Okay, so don't forget to comment your name and your class below and fill in my Google form attendance. Okay, so thank you very much. See you next week. Bye.